This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
For Software Engineering Radio, this is Robert Blumen. Today, I have with me Sam Boyer. Sam is a principal software engineer at Grafana Labs, contributes to open source projects, especially in the Go community, and he's the author of the article, So You Want to Write a Package Manager, which will be the subject of our conversation today. Sam, welcome to Software Engineering Radio.
Thank you for having me. I'm delighted to be here.
Is there anything else you'd like listeners to know about your background?
I can do the quick things. I'm a self-taught engineer. I started in the industry about 12 years ago. I've been working in open source for a long time, and it was in large part my interest in the way the communities work that drove me to my interest in package management in the first place.
Great. Before we talk about package management, what is a package?
So this is a totally natural place to start, and it is a surprisingly subtle question. So most people, most of the time, think of, the packages they work with in terms of the actual systems they're in, right? You know, if you're writing JavaScript or TypeScript or whatever, you're going to think of NPM packages and package JSON and like the contents of that. You might also think of system packages or system package managers for your old apps or your RPMs or more modern like Kubernetes-y things. But if you actually want to like give a sufficiently general definition of what a package is, it's kind of frustratingly useless. Like the best one I can give is that a package is a collection of stuff with a name and some kind of logical boundary that separates the stuff that it contains from other packages of the same kind and their stuff within some larger context. And that is it's like I said, frustratingly abstract. Like stuff can be source code or compiled code or configuration files or a bunch of cat GIFs. Like what's the contents of the package and what it means to be a valid package is a function of the ecosystem that the package is from. It's an NPM package. It should have certain properties. It should have a package JSON. A Rust package should have a cargo toml and I think a non-zero number of .rs files. This is one of the weird subtleties of package management, though. It starts right at the beginning. It's hard to actually pin a really precise definition on what constitutes a package.
It might help people to understand if you could pick one language and talk about one or more packages in that language to illustrate it.
Okay. Offhand, oh man, what would I pick? So in Go, we could talk about Go where the thing that we think of as packages elsewhere are referred to as modules. We could talk about like the Go Kit package, sure, popular microservices framework. And so that is there's a Git repository that the actual process of developing the code is done in. But what we would think of as a package itself is a Git tag that is attached to a particular commit to make a release that refers to then the snapshot of all the files in the Git repository. And the identifying features of that Go package would be all the Go files themselves, and then the metadata files that communicate information at the package level, the go.mod file, the go.sum file in the case of Go.
Okay, so packages, so it's a bunch of code that I might want to use in my program, so I don't have to go to the trouble of writing it all myself. And then there's some metadata. If it's too hard to answer this in general, talk about some things you might find in the metadata. You could pick a particular language.
Yeah, well, I mean, the most important things that you're going to find in metadata, you're always going to find a name, and you may or may not find a version. Sometimes that is considered to be something that is held inside of the package, but it always has to be something that's also like outside of the package so that other things can refer to it. But that's sort of your 2-point coordinate system in the universe of packages is you need to have a name and then a particular version of that name. Go ahead.
Yeah, I don't only want to use a Go Kit package. I need to know that I want 2.1.
Right.
And they might release 2.2, 2.3, but I'm not ready to upgrade to 2.3. So I want to stay on 2.1, something like that.
Yeah. Those are the two absolute essentials. The other major thing that you will typically see in these metadata files is you'll see a list of dependencies, a list of other packages required by that package, and possibly also some construction about the version that's supposed to be used with those.
The answer to this is going to be in a very broad ranges. If I'm building a product, let's say it's a commercial product that is running for a business somewhere, and so I'm going to build a server, how many packages might, if we look at the packages and their dependencies, and we have to go all the way down to the bottom, are we talking tens, hundreds, thousands? How many packages does a typical modern software application need?
So it really depends on the ecosystem. You're going to see a lot more in the NPM ecosystem than you would in the Go ecosystem or the Rust ecosystem, for example. I don't have I'm not sure that I would be able to meaningfully construct like an average number, if only because you can't, even if I had access to all the private software written everywhere in the world, then I could construct like an average number, but there's a selection bias involved with polling only the open source available ones. So I think the best I can say is, yeah, you might see thousands in JavaScript land, and you might see tens to hundreds in like a Go or a Rust. And I think most of the other, JavaScript's really the one that is like an order of magnitude more than most NPM. Yeah.
This means that if I am shipping software, that most of what I'm shipping is stuff written by other people. My contribution is only a tiny amount. You get into this a little bit in your article when you talk about...
Maybe we want to talk about what a package manager does first. That actually might be a better way to segue into this.
Well, let's move on to our main topic, which is we need some kind of a tool. I think that's motivated by, if there's thousands of these things, it goes beyond human comprehension to keep track of all the packages. What problem does a package manager solve?
So, I mean, the obvious thing that it does, right, is it downloads a bunch of stuff from the internet and puts it in places on disk so that you can run programs. So in a sense, it's an automation tool. But I think that as with a lot of automation, the value is not so much, certainly there's value in keeping from having you to do rote tasks over and over again, but it's in the uniformity of the way that a system is created on the other side of running a package manager command. All of the same packages at all the same versions. It's part of a reproducible build concept, that when you have a tool that grabs everything in a uniform way and lays it out in a uniform way, it removes, the goal is usually to remove unnecessary choice from the operator in terms of how all these dependencies are arranged.
Okay, so it's going to ensure that you have reasonable versions of all the packages that you need so you can do a build. Is that a fair statement?
Yeah, the word reasonable is incredibly important here, because version selection is the core of all of this. Which versions of the packages do you actually want to use? And my stance is that we should actually think about the job of a package manager as, at least by default, its job is to pick the correct version, which itself is a term that we need to unpack, but it sets us in the right frame of mind that the real job of package managers is to be a system that has an opinion about what it means for the artifact it creates on the other side, the composition of your code and all your dependency code, to be correct and to enforce that and to tell you when it can't meet that. Yeah.
Okay, we're going to come back to the dependency versioning issue and discuss that in depth in a bit. Could you toss out the names of some popular languages and frameworks and the package managers that go along with them?
Sure. There's Node and NPM or Yarn, and then there's Rust and Cargo, and Go modules is the way you should probably refer to it.
We're talking about commonalities to something that exists in nearly all different software. Is the package manager usually issued or built by the same team that built the language itself, and it comes as a part of a toolkit that if I download Python, I would get the Python package manager? Or does there tend to be competition among package managers, even within the same language community, where different developers have a different idea of how package management should be done for language A, and so you would have a range of choices even within language A?
Yeah. Nowadays, I think it's pretty well accepted that you really can't ship a language without shipping a package manager, or at least not if you want any kind of community to exist. But that's not always been the case, certainly. So there is a shift in this over time. Older languages, there's more separation between like the language tooling and the package manager. Newer ones tend to build around it.
Would the package manager be written in the same language as the primary language?
Yeah, almost always. The main limit here is that you absolutely have to have your package manager be executable wherever your language is executable. And as nice as it might be if like we could write the mother algorithm for all package management in like one language, you end up in a really awkward situation as a language designer if you're having to juggle between your compiler or whatever and like what platforms it can run on, and then your package manager not being aligned.
For example, Python itself is built in C, but I wouldn't necessarily want to have a C compiler just to build a Python package manager. It should be written in Python. Okay.
Yep.
Now, take Python, it's a language I'm familiar with. There are many packages which are built into Python. I don't need to manage them because when I get Python, I get a bunch of common packages. Is it a requirement that the package manager only depend on built-ins so that we don't have to package manage while we're bootstrapping the package manager?
I mean, I think that's mostly a question of that more has to do with the previous question, right? Like, is the package manager a part of the tool chain that's distributed with the language? If it is, well, probably yes. We're not going to depend on anything external. If it's not, then you have more degrees of freedom there.
Okay. Package manager, you mentioned that it goes out to the interwebs and finds things. Where does it go to find the packages?
Yeah. So there's a few approaches. Most package managers rely on some kind of central repository. I would say you can really say there's four models. You can have the model where there is only one central repository. You can have the model where there's like a search algorithm that picks between multiple repositories that can be specified. You can try to go fully distributed and use I've seen a couple of blockchain related package managers that want to like store the packages on the blockchain. So your addresses are not going to a server. They're instead going to this distributed address resolution system. Not finding good words there. And then you can go for something more strictly like URL shaped, like the actual names of your packages are URLs effectively. And so you're relying on DNS to give meaning to names, at least at the highest level, instead of a central service.
So if it's built into the package manager, there's one repository, everything's there, it goes there. We could put the name of the repository in the code. If there are several, or I want it to be configurable, would there be a setup step where I issue some command like add remote repository followed by a URL?
Yeah, if that's the model that's been chosen by the creators of the package manager. The scope of this ends up being really important, right? Like for a system package manager, you might configure at a system level, in your Etsy directory, some additional repositories that get used, right? That way all users share them. One of the main issues is that since we're ultimately talking about name resolution here, is in order to have multiple repositories, you have to have a way of distributing the names of all of the name resolution services effectively to any client that's going to end up trying to resolve all those packages, because otherwise you don't have the same uniformity across all of your users. That is so important.
Within an enterprise, there could be security reasons or availability reasons why you might not want to pull everything from a remote repository, or perhaps the amount of bandwidth going over the network. Suppose we want either to run our own repository or have caches or mirrors on an internal network? Is that a common use case? And do all of these package managers support that?
It's a range. It's certainly common. There's any number of reasons, whether it is performance, security. I guess those are the two major broad categories of reasons that jump to mind right away. Actually, I suppose it would be performance, security, and then also correctness in the sense of ensuring uniform name resolution, again, would be the major reasons that people want some kind of intermediary to not just have things touching the interwebs. The manner in which these are supported varies. I'm not aware of any like general framework for being able to talk about it, mostly because the way that you would inject an intermediary is largely a function of how your name resolution works in the first place. And so it's dependent upon something that varies in the first place across package managers.
How does the package get pushed up into the repository?
This is, it's very clear that package managers are responsible for the read step. They have varying degrees of responsibility for the write path. It's more common when you have a repository that you maintain yourself that is specific to your ecosystem of packages, that the tool will bundle in the write path. But this also gets into like the nature of what your package actually contains, right? I mean, you're making a release, so you generally want to like hook this kind of thing into a CI workflow, something that gives you assurances that the thing you're about to release is correct with respect to whatever rules you've devised for your package. And yeah, then you have to figure out how to map I think what I'm trying to say is like with respect to the tooling, the job of the people writing the package manager is to probably be as non-invasive as possible into people's workflows, because people are going to put a lot of different things together when it comes to being sure that they're actually ready to make a release, and trying to bake too much of that into like what you would write in a standard tool for package management ends up hindering, because you're cutting off certain workflows that will be important to people.
So if I have a compiled language, maybe my source code is in GitHub, I've decided this code, it's passed all the validations, we're ready to release 2.4. There would be some workflow I would go through which might involve compiling and creating libs or jars or whatever the archival format is, and then pushing those up into an account that I have for our project on the repository server. Is that what the workflow looks like?
Yeah, more or less. Yeah. Perhaps it's something that, I mean, especially nowadays, I would expect that this kind of thing is something you would create an automation for, which is very important. I mean, again, the goal with packages in general is this uniformity of the package object, and removing as much a necessary source of user error in the process of both creating and consuming these things is essential to reliability. So yeah, automate that. But in general, yeah, what you described is the way that one should imagine using it.
Do the package managers support an API that looks like, give me all the versions you know about of this package by name?
Usually, yes. It's almost impossible to write a version selection algorithm without having knowledge of the universe of versions.
Are there validations like code signing to ensure that what you get is the trusted package that you asked for?
Yeah, this is, I mean, the tricky thing here is, since we're down at the level of like giving meaning to names, you can easily get into canonicality issues when it comes to like verifying the original upstream source. If I have a repository in some configuration file that I have added, then that thing needs to be the thing that I check against for the validity of the package name that I'm asking it to resolve. But if someone can attack like the config file that I have about which repository that I talk to, then how do I know that my verification is correct? There's the whole field of, software supply chain security is invested in trying to formalize a lot of the answers to this so that we at least don't have a lot of unforced errors in this area. But yes, certainly that can be a part of the process and can be considered an aspect of what constitutes the correctness of a package.
That is a great topic. I would like for us to do an entire hour, or software engineering radio to do an entire hour on supply chain security at some point. But to continue with our discussion, what does the developer workflow look like when using a package manager? And if there isn't a general case answer, then let's pick one language that you can talk about. What are the commands that the developer runs?
I mean, there are a pretty general set of commands, right? And they are essentially, they're CRUDish. It's, I want to add a package. I want to change the version of a package. I want to remove a package.
Add a package.
And here we're talking, here we're talking like, this is the developer working on a project, talking about the dependencies for the project that they're in, correct?
Yeah. Let's drill down into that. So add a package is, I've decided I need to do some feature in my program, and there's a package for it. I know the name, I know the package I want. So I'm going to add a package. Do I have a config file that tells the package manager, here are all the packages I want? I go and edit that config file, and then I run a command like sync or add.
Can be. It varies. In general, the two interfaces to package managers are a command line interface and then a file, because you certainly have to record state in order to be able to do anything with a package manager. You have to record dependencies. It's typically far more convenient to offer people a command line interface to do most of these things, more scriptable, et cetera. Because then the other thing that you can do, which is especially important for automation purposes, is if you're able to have the tool take its action and then update the written file, this is usually the most preferable flow.
Not sure I follow what you mean by that. Do you mean if I add a package to the code, that the package manager might detect this package is missing, I need to add it to the package list?
Yeah, that if I say, add dependency foo in my terminal, I do package add foo, then when the command completes, if the command completes successfully, I should be able to expect that package is present and available on my file system, or whatever it means for the package to be available, such that when I go to execute the program, the linker, the loader, whatever it is able to get at the contents of the package. So I can expect that requirement is satisfied, and also that a record that the requirement of the package exists is written into this thing we usually call a manifest file.
I realize I don't like this package. I'm going to remove it from the code. Mm-hmm. What does the remove workflow look like?
So the main thing that's really tricky here, right, is that usually the question is what the relationship is between the metadata file and the actual code base. Like if you have import statements that continue to reference a package which you are trying to remove, I'm not really sure why you're trying to do that. There are reasons to do it, but there isn't a general case for it. So what we're really talking about is a synchronization relationship between the dependencies as expressed in the code and the dependencies as expressed in the package level metadata. So what are you referring to the case where usually what this entails is the developer needs to go in and excise any references to the package from their code, and the final step is just remove it from the metadata file.
Yes. Okay.
Yeah.
Now I think would be a good time to start going into dependencies. You talked about this a little earlier, where I like this package, it does something useful, I'm going to add it to my package manager. This package, because it's software, it relies on other packages, which are its dependencies. So you have recursive process. So before I ask you some more questions, is there anything you'd like to say generally about dependencies, and then we'll get into some more detailed discussion?
Sure. So the graph of connections between software packages and the packages that they depend on, and certain key rules about this graph, which include, certain key rules about that graph are some of the most important fundamental properties of any package ecosystem. And I'm sure the next questions you have will drive us right at those.
Clearly, we don't want circular dependencies, but cycle is a property of the entire graph. How does the developer of a package ensure that they're not depending on something that is in the wrong layer and would potentially create a cycle.
In general, they can't. I mean, because as you noted, it's a property of the graph, right? Certainly, I'm not sure that there's a general answer to cycles. Most package managers do allow cycles of some kind, at least, primarily because it's mostly like not up to an individual developer to resolve that. Like it's literally kind of the definition of a cycle, right? Like it's no one person's fault. If there's three, well, no, it's no one person's fault if there's a cycle because the arrows go in a circle. Whether or not you can construct a sane logical system on the other side of there being dependency cycles tends to be the challenge and the reason why you wouldn't allow cyclic dependencies at the package level. Yeah.
Okay. Now, we've established if I want a package, I have to specify the version I want. The package itself is going to specify versions or maybe a range of versions of its dependencies. How do versions and dependencies interact?
So yeah, this is one of the most important properties for any ecosystem. I think I'll talk first about like ranges versus. First I'll talk about what Yehuda Katz likes to call the Highlander rule, and then I'll talk about version ranges. So every package ecosystem needs to make a decision about whether, given A and B and they both depend on C, every package ecosystem, or rather the thing consuming the package ecosystem, needs to decide whether there are two instances of C or one. One for A, one for B, or one that they both have to share. And the semantics of that are complicated. They have to do with what actual kind of artifact you're trying to create on the other side of putting A, B, and C together. It tends to be that compiled languages, or at least statically type-checked languages, have a lot of difficulty allowing that duplication. It's necessary to come to a compromise on the version so that there can be exactly one instance of C, so that names have proper meaning, so that you can let types flow through the program and not have your type checker blow up. Dynamic languages can get away without it. And sure enough, NPM, until recently, at least until NPM 7, basically namespaced everything. And most other languages don't. They follow the rule. There can be only one. This is the source of the Highlander reference. There can be only one C.
Okay. Let me give an example. If I'm bringing in different packages and all of those packages use logging, it might happen that package A says, I want 1.4 of the logging package, and package B says, no, I want 1.5 of logging. You're saying there are two solutions. One is, great, we have A uses 1.4 and B uses 1.5. We have two versions of logging. Now, that might not work because, and this could depend on the language runtime, that logging is some kind of a unique name in the language. You can't namespace it. So no, you have to agree. Or just because of the nature of what logging is, maybe the log aggregator you use, you can only have one of them. Those are the different options you're talking about, correct?
Yeah, So if you have, let's imagine that we have A depends on B and A depends on C. B and C both depend on logging. The question is, from a type checking perspective, is it possible that any of the logging types flow back through B and C back up into A and need to be the same type because they actually rejoin in A and the type checker needs to approve that all these types are valid? If you're in a language where you do have a type checker and we have to be sure of that in order to compile, then it's generally not feasible to have multiple instances of C because they have different names, they've been namespaced somehow, and the type checker is going to blow up. In a dynamic language, you can get by without it. The other thing is what you're talking about, where essentially if C relies, usually it's a global state question. If C relies on some kind of, global state or external resources question, but it's effectively the same thing. Like if the conventional thing gets talked about here is more like a database connection. If C has a database connection embedded in it somehow, you don't necessarily want to have two copies of it because you don't want two copies of a connection to your database.
In some languages, there's a concept of global variable. The language would not allow you to have two global variables that are different but have the same name. So in that case, you have to agree on, There's,
Right.
say, an object called logging, and it's a global variable. In some cases, that can only be one.
Yep.
Okay.
Yep.
Now, what am I going to see if I run a package add or sync command if it detects an issue of this type? What am I going to see in the output?
So this is where it gets very interesting. In the first easy one to talk about is a language which does not follow the Highlander rule, right? You can duplicate logging. I mean, in that case, like, we don't have a problem, right? What you're going to see is success. Great. We picked this version of logging for A and this version of logging for B. In a language where you do have to solve the problem, there are a few different options. And they really depend on the way that the version selection algorithm for that package manager works. So there are some package managers which use a version selection algorithm that essentially can't fail, perhaps even when it should. So there are advantages to this approach. Mostly algorithmically, it's faster, and the behavior tends to be more predictable. So even though you get, even though you can plausibly get an outcome which won't actually compile, you at least don't have odd failures, because the problem is the failures get really complicated too. So if you have a version selection algorithm which sees the problem and tries to do something about it, we're now talking about a search problem, effectively. Can we find versions of B and C which can agree on a version of logging? And then we get into the question of what agreement means. But the output that you may see in that case, it'll vary widely. It varies depending on whether or not it was possible to find a version of logging that B and C agree on. Because if it was, then the package manager probably won't tell you there's a problem. It'll just say, I picked this version because it appears to satisfy constraints. If it did fail to find a version, the output can be potentially very complicated, because it may have gone, in order to exhaust the possibility space of all the different versions of B and C, it may have a whole lot to tell you about all the things that didn't work. So there's a range of output you may see.
An example we gave a few minutes ago, we were talking about package B1's logging 1.4 and package C1's logging 1.5. You could imagine package B says, I am comfortable with 1.4 or greater up to 2.0, and package C says, I want 1.7 or greater up to 3.0. There is clearly an intersect of things they could both agree on, but there could be more than one right answer. How does a package manager choose? You could have a range of acceptable versions. How does it choose?
So that is effectively, that question reduces to how does a SAT solver work? You have a range of possible versions. In general, the simplest way to think about it is latest version acceptable from all parties is the one that you should get. But that is actually a deeply insufficient answer itself, because just because you're running version selection doesn't actually mean that you want to update. Like, if B requires logging 1.5 and C requires logging 1.4, and you're A, and you're pulling in B and C both at the first time, well, if there's a version of C that is 1.6, does that mean you should get that version of C that's 1.6? Because that's not the version that either B or C asked for in the first place. There's a range of considerations here that are not easy to resolve in a straightforward way. The thing, though, that I think is important to point to is that not even if, it's easy to look at these numbers and almost be like, oh, this is fun. I get to write an algorithm that solves constraints. But the reality is that those constraints that are written down are almost certainly wrong. Almost anything that you write down, at least if you are asking of your version range, version constraint system, if you are asking the user to make a precise statement about which versions of its dependencies the software actually works with for a range of reasons, that is almost never going to actually be correct. So this is why, so people talk about dependency hell, right? The problem where you're trying to essentially negotiate between B and C with logging, right? You're A, there's B and C that depend on logging. They disagree. which version works. I think actually it's more interesting to talk about dependency limbo and dependency hell. Because I think we spend a lot of time in dependency limbo where we're confused about the output from our package manager, and we are unsure as to whether there does exist or not a version of logging that will satisfy B and C. And there's two branches of that question. There is there a version of logging that will satisfy B and C according to what they've written down? And then is there a version of logging that will satisfy B and C according to reality? Will my code actually compile and be correct, whether or not the things that B and C wrote down about logging actually are satisfied? So dependency hell, I would say, is when there's a real problem and it won't compile and your code's incorrect. And dependency limbo is when you're just not sure.
Let's delve a bit more into dependency hell. Would this be where I run the sync, it says you get two conflicting versions of logging? One of your packages needs 1.4 or less, and one of them needs 1.5 or greater. So I say, okay, I'm going to upgrade some things to get on a higher version of logging, and that should resolve that. And then it breaks something else.
Sure. I think there's many circles in dependency hell. And the problem is that because ultimately we're at this 10,000 foot view of the actual behavior of our software, and we're trying to make really coarse-grained choices to arrange things in our dependency tree just in order to get things to work. Yes, certainly. I change in order to deal with B and C's issue with logging, I update other things and then things break over there. It ends up being a problem where you can suck in the entirety of your application just trying to fix one problem. And it's difficult to tell which way is even up.
I could imagine this happening. We're talking about logging, which is something pretty concrete. I usually know which logging system I want to use. But it could also be that I'm pulling in some very high-level packages to do something like machine learning, and 7 levels deep, they give me the name of something that's live grpnf 0.3. I don't even know what that does. I never asked for it. I don't want it. I don't know what the risks are if I say, just go ahead and use this anyway. And I wouldn't really know how to resolve it. What do I do, Sam?
You mourn that dependency hell is real. I mean, this is why, again, I kind of like the limbo thing more, is because what is hellish about the experience so often is our uncertainty about what is okay to do. We are often solving problems that are not our own in some deeply nested set of packages. Why did they make these decisions? Are these constraints real? Can I violate them and still have things be correct? How can I be sure that things are correct on the other side of violating them? How can I be sure they're correct even if I haven't violated them? It's this series of questions that is usually these systems work well enough that certainly we all get by with them, but there's this cliff, and much of it involves just the gray uncertainty about how to fix problems when they arise and whether problems exist in the first place.
Is there typically a command or setting where I can, and perhaps that's what you mean by dependency limbo, I can make the call that this package says it needs 1.4 or high, or 1.4 or less, but I am pretty sure it's going to work with 1.5. Developer did not upgrade, is a bit too strict. So I'm going to say, package manager says you have these two conflicting versions, 1.4, 1.5. I can say, go with 1.5. I'll take the consequences.
Usually, yes. These are referred to, typically the general term that's used to refer to these is some kind of override, right? I, from the root of the package graph, want to supersede something down. I have to fix a problem, so I'm going to supersede something that one of my dependencies has said. The classic problem with overrides, though, is that it's really only a power that can be given to the root package in the graph. It's not that there's no way to. The reason that we have these issues in the first place is because, B issues a constraint on logging and C issues a constraint on logging. And we error out if we can't find anything where their constraints can be made to agree, right? The point of an override is, well, this has higher priority than everything else. But as soon as you're down in the depth of, if B had an override and C had an override, wouldn't matter because now we can't pick one, which, supersedes. So what this creates is if you end up having to rely on an override switch as the author of a package, I've referred to this as contagion failure because If you have to write down an override, then anybody who depends on you has to copy that override. They have to hoist it into their own metadata in order to get the graph to resolve in the same way. And it's usually invisible to whoever's depending on you that they need to do so. So it's this just like spread of overrides that goes through the package graph, and the deeper it gets, the worse it gets.
Sounds very fragile. If then you upgrade something, it probably breaks all the overrides you did.
Plausibly. Yeah. Depending on how overrides are phrased, it certainly can. Like if you were saying use version 1.7 instead of version 1.8 of logging effectively, but then like the version of logging that was being used changed. Now you're not replacing 1.7 anymore because 1.7 wasn't the version that was there in the first place. And you're like override statement's ineffective. How do you even know that happened? The problem metastasizes.
I think now would be a good time to delve a bit into the internals of Package Manager. We've talked about some of the components. There's the project code that has import statements, some kind of a manifest file. So at least two more components. Next one would be a lock file. Please talk about that.
Sure. So, a lock file is really the result of a version selection computation. I went through, and the idea is I want to record the exact set of dependencies at a given moment in time, transitively. So you have the entire graph written out in a file. These are all the dependencies. These are the versions. It is not strictly necessary, depending on the package manager, to have a lock file because it depends on the algorithm. If you have a stable algorithm, then you don't necessarily need to have a lock file. This is why Go modules doesn't have a lock file, because the algorithm is stable. Stable is an imprecise word. Because the algorithm never picks the latest version, it means that given a set of specific versioned inputs, you can walk all the way down through the graph and know that you'll always get the same set of versions, modulo certain details. But version selection algorithms, which do like default to latest, need to have a lock file because otherwise there's no way to have reproducible builds at all. But ultimately, the goal of the lock file is this reproducible build property. If
you had something which could pick latest, then latest could change because the package developer has pushed an update.
Yep.
And so you don't have a reproducible build now because it depends on something external.
Right. This is often referred to as, like, people often refer to this sort of ambiguously, actually, but as version pinning. Like, I want to use exactly a version. The ambiguity tends to be whether you've written down, whether it's pinned because it's the version that you have written down in the lock file, or it's pinned because it's the version you've written down in the manifest file. The meaning of having it in the lock file tends to be, this is what I'm using right now, and we want it to be reproducible, but it could change. Whereas a manifest file says, I will use this version and only this exact version. It's a constraint statement, right?
Depending on the language, if I have the lock file, then would the build system typically support the ability to do a build, and here's the lock file, don't run the package dependency algorithm again? We're starting in midstream because we've already run it.
That's really, it's a good way to think about the lock file is, like I said, it's the result of a version selection computation. So the presence of the lock file is usually used as an indication that use the versions that are here. We don't need to rerun version selection. We've done it, and this is the version that we committed to. So, continue forward in your build system. I do think there are interesting possible universes where we could do a lot more like version selection further down in our pipelines, in our CI pipelines, our delivery pipelines, but it requires some new algorithm and some new thinking about how we encode this information.
What would be the advantage of doing that?
So it would be that instead of having to, like, you could imagine the context of perhaps A/B testing, or, well, if you had the ability to change the set of dependencies being used for a given piece of software, perhaps not on the fly, but that you could change it somewhere later in your build pipeline, instead of having to like have multiple build pipelines where you expressly commit a particular version to be tested, and now you're like back in Git land trying to think about this maze of branches that you've created, you can express a combinatorial set of build variations that you might want to test that are like a logical consequence of like a matrix of versions or a matrix of constraints that you pass to the algorithm, and have some knowledge of which versions will actually be tested. That's one thing. Anyway, this is a relatively distant concept, so I'm not sure how it would end up being used.
Could there be an example of this where there's some library that's very low level, it has tremendous throughput like networking, and I want to see if I bump a version, if I either have a performance regression or performance improvement. And so I could do that by changing the version in the manifest or the lock file and putting it on a branch and building that branch. But you're saying
I think that you could imagine designing checks which want to continuously check against some range of versions for some library, some particular property. Yeah, like the performance of some networking throughput library. The advantage of this, it's hard to talk about because there's a few. This is something that I'm working on, but it's hard to talk about because there's a few concepts that you need to have kind of before you can get to the value of it, and like explaining the concepts that get there is kind of out of scope. The simple way of saying it is that you need a language that you can use to express which versions are acceptable to select, which is then sort of usable on the other side to talk about which versions have been selected relative to what is like committed to in a log file. And that can then be used to like parameterize your concept of what your build actually looks like. But I think that's probably the most comprehensible way to say it, and I don't think it's very comprehensible.
The last component would be the dependencies themselves. Where does the dependency manager put them after it grabs them off the internet?
Yeah. So, I mean, again, of course, this varies significantly from package manager to package manager. And the question there is really tied to the behavior of so given that packages are tied to a particular ecosystem and there is an intent of using packages in a particular way, whether it's an interpreter or a compiler or as an intermediate stage to like a larger to something larger, there is some program that is going to tie together all these dependencies, and it has to know how to locate them. So this is really sort of a how do I locate things problem. The OG package manager is really, when we think about system package managers, those are actually C package managers because we didn't really make this distinction between all of the code in our lib directory, which was going to be used by C, and I'm package config, which would actually go and like locate packages for you on disk. For most other languages, though, this is a more self-contained problem, and the way that packages get arranged is mostly a question of sort of lookup convenience for the language. The main thing to say about it is kind of a note that like what gets weird about package lookups is this is where you tend to want to do something like aliasing or some sort of override methods. And some of it is important, but if you give too much flexibility to the user to be able to just sort of rename packages all over the place, people will use it for things that end up getting their program into just an incomprehensible state because we're effectively overriding names upon overriding names or messing with things with where they are on the file system. In general, where the packages live should be the most boring question that you can possibly ask of a package manager. It should be rote and simple and dumb because doing anything else makes things really confusing.
I was going to ask you this question about the lock file, which I forgot. So I'm going to combine this with the question about dependency. Should the lock file be committed to your SCM? And what about the dependencies when they're downloaded? Should those be committed?
I'm agnostic. There are reasons to do it. It's easy to point to things like left pad, which is decade old now. I don't even know how old it is. Where people have pulled packages from public repositories, and you're trying to like guard against that. Sure, but most of the strategies for trying to defend yourself against like the world changing tend to have a limited shelf life. I'm not saying that they're wrong, and everybody has a different way of sort of thinking about the risk profile here. In general, I tend not to commit my dependencies, but there is, I view it as mostly like a sort of risk assessment argument that reasonable people can disagree on.
Language like Go or the C language is the end of the build systems. It produces a binary which may incorporate all of the libraries to the point where you don't need them. I understand there are some things that have dynamically loaded libraries compared to Ruby or Python where you need the packages because it's interpreting them at runtime. And so that would be a stronger case why you should possibly check them in because you can't deploy without them.
I mean, the question there is whether you want failure to happen at deployment or like failure to happen with your developers. Failure is still happening. I'm not sure how meaningfully different those things are, and that may depend on your context.
So we have a bit of time left. You had a discussion in your article, and if you can condense this in the remaining time, the steps that happen, we've talked about the components. Broadly, what does the thing do? What are the steps that happen when the package manager runs, referencing the manifest lock file dependencies and other state?
The steps. So when it runs, referring to our get or add, remove, or change,
Yes.
Which one?
Let's do add. That's probably what we have time for.
Sure. Yeah. So really what's happening here is we're trying to reconcile a few different states, right? We are, depending on the language, possibly trying to scan over source code. Like you can do this in Go, scan over the source code to look at import statements and try to ensure that all of those are satisfied. That's something you may be doing. And you may be doing that independent of which command you're running. But with an add command, the basic validation that you have to do in the command initially is like, well, is there actually a thing to add here? Like if you try to add foo and foo's already in your manifest, then what are we doing? It doesn't make any sense. But once we've established that like it's a sort of valid request, then you have to resolve the name. How do I know what foo is? And that's going to depend on the choices we were talking about earlier for the package manager about what thing you use to resolve names. And if the thing resolves, you're going to fetch it down. And at that point, you have to then kick off. Well, what you really have to do at that point is you have to kick off version selection because there's no way to. This is the thing about version selection because it's all a graph. You have no way of knowing a priori which packages might depend on which other packages. In order to add A, you have to reconsider the entire graph. So you run through a version selection process to basically pick a new version for all of your dependencies, and including A with that. Then you, assuming that was successful, you get a return out, and that ends up getting piped back to the user. Ideally, that manifest file gets updated, and the lock file gets updated as well, and you get a successful return to the user.
I think that's a good place to stop. Sam, we've covered a lot of ground here. I hope the listeners have a better understanding of this somewhat murky area than they did an hour ago. Before we wrap up, is there any place listeners could find or follow you that you'd like to point them at?
I'm on Twitter at SDBoyer.
Any
Don't
open
tweet
source
much nowadays, but yeah.
Any open source projects?
So I have a new thing that I'm working on, which is not unrelated to package management. The repository is, well, in a week, it should be much more consumable, but I'm calling it Schemata. It's written in the new language Q. It's a system for writing schema, but it's a system for writing schema that lets you evolve the schema over time, including across breaking changes, and encapsulate all the logic for writing the schema and dealing with the breaking changes into one place. And that's at GitHub/Grafana/Schemata. And I assume that we can put, well, should I spell it out? How should
I'll put it in. I'll get
spell.
it from you and I'll put it in the show notes.
Cool. I think that's probably the most interesting thing. It's like I said, not unrelated to package management, but has much more to do with the way that you deal with breakage, which is certainly a major topic in package management.
Sam Boyer, thank you very much for speaking to Software Engineering Radio.
Thank you. It's been great.
This has been Robert Blumen. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.